Okay, hopefully this goes a little bit smoother than 7th grade's last video, and hopefully mine stays recording the whole time. Okay, so for 8th grade we have, our next lesson is 7.2.1, and it's titled, What is the equation of the line? And it's y equals mx plus b revisited. So it says, previously you developed ways to find the growth of a line using its rule, table, and graph. You also learned how the y-intercept is present in each of the representations. In this lesson, you will enhance your study of lines and will develop ways to find the equation of a line using different pieces of information about the line, such as 2 points that are on it. Today's lesson will help you review connections you made in previous chapters by challenging you to find equations for lines from multiple representations. I'm just going to write, for the sake of referencing this, y equals mx plus b, just like the poster in the classroom. The b is our y-intercept, where it crosses the y-axis, and our m is the pattern of growth. I don't know why I just did that in black, but I meant to do it in red. All right, so that's for reference. So it's only assigning one problem for us to do, which is 7-35. And it's called The Line Factory. And it says, congratulations, you've recently been hired to work at the city's premier line factory. People from all over the country order lines from your factory because of their superior quality and excellent price. Lately, however, the line factory is having a serious problem. Too many customers have placed orders and then have received lines different from the ones they wanted. The factory has hired your team to correct this problem. Now, if we were in class, we would probably be separating this problem up into people doing different parts of it in groups, but we're just going to do all of them together. So it says, our task is to review the recent orders below and decide if there's anything wrong with each of the customer's order. If the order is correct, pass it to your production department with a rule, a table, and a graph. It says on graph paper, but I don't have graph paper, so we make do. If the order is incorrect, explain to the customer how we know it's incorrect and suggest corrections. Okay. Customer A. And I'm just reading right from the book, making sure that it's recording, and it is, thank goodness. Okay. Customer A says, let me go like this. They want a line that has the y-intercept at 0, -3, and it grows by 4. So this customer ordered the line y equals -3x plus 4. Now we need to tell customer A if she is correct or incorrect in the line that she has requested to order. So what I'm looking at is her y-intercept is -3. And if we look up at our original y equals mx plus b, the y-intercept needs to be at the end of our equation. And I'm looking at her equation, and it doesn't look like it's -3 right here. So it looks like she's incorrect, and it looks like she flip-flopped the mx and the b. So instead of putting the y-intercept at the end, she put -3x, and then she put plus 4 because she thought that that's where the pattern of growth goes. And I saw a few of these mistakes on some of our tests that we've done in 8th grade so far. So be sure you remember that the b is our y-intercept. So I'm going to say that she's incorrect. And I'm going to say what her actual line that she meant to order is. So she's incorrect. She needs to order the line Let's correct her. So she needs to order the line. We start with the pattern of growth. So her pattern grows by 4x. Then her y-intercept comes next. as a -3. So she should have ordered the line y equals 4x minus 3. One customer down, and I think there's 4 more to go. Okay, that's customer A. Let's look at customer B. Customer B, oh, so it shows you a graph, and I'll take the phone off my thing and show you the graph, but he wants this line. Customer B wants y equals 3x plus 2. So once we look at the graph, which is right in your book, you want to notice if the line intersects the y at 0, 2. Does it? And do we have a pattern of growth of 3? So let's look at the, okay, we're looking at the graph now, and we're looking to see if it matches. Does this graph match y equals 3x plus 2? So let's see if it intersects the y. Here's the y at 2. So let's see, 1, 2. It does. And let's see if the pattern is up 3 over 1. 1, 2, 3 over 1. Up 2, 3 over 1. Uh-oh. It looks like they have a negative pattern of growth because it's going down 1, 2, 3 over 1. 1, 2, 3 over 1. So instead of positive 3x plus 2, this customer needed to order negative 3x plus 2. So they got the y-intercept, sorry. I'm trying to get this back on its holder. Eek. Okay, sorry about that. I'll try and cut that part out because that was annoying. Okay, so customer B needed to order so he is incorrect. His line should be y equals negative 3x plus 2. So he was off just a little bit. And that's okay because we're here to help him. All right, customer C. Customer C wants a line that, okay, so customer C wants a line that passes through these 2 points, so through the points 2, -4, and 5, 2. She ordered this line, y equals 2x minus 8. So what you could do here, and this is what I did to figure out if customer C was correct, you could graph it first. What I did, just to be more precise, because our graphs aren't always really precise, especially if we're not using graph paper, I took both of these sets of points. So this is our x and y, and I plugged this set in first to see if it worked. And in order for it to work, it has to be equal on both sides. So I started with the equation y equals 2x minus 8, plugged in -4 for the y, 2 times 2, that's our x, minus 8, so -4 equals 4 minus 8, and -4 equals -4. So that point is correct. So far customer C is right. Let's try for this set of points. So let's plug in our y first, which is this 2, and then plug in our 5 for x, so 2 times 5 minus 8. So then 2 equals 10 minus 8, and 2 equals 2. So that point also works. So both points work, so it looks like customer C ordered the correct line. So it said if your customer orders the correct line, to include the graph, include a table, and include the rule. So we've got the rule already, y equals 2x minus 8. So we need to, I'm going to erase this work, we need to draw a graph, and we need to make a table. Okay, let's do the graph first and get the graph out of the way. And I'm going to do it, yeah, I'll just do it right here. And I'm just going to make a quick graph. I'm not doing anything fancy here. 1, 2, 3, 4, 5, 6, 7, 8. And I'm making sure it's at -8 because that's where it's going to cross the y. 1, 2, 3, 4, 5. Okay. So we're starting at 0, -8. That's our first point. And our pattern of growth is up 2 over 1, up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, and that's probably good for us for now. And I'm going to try and draw it as straight as possible. It wasn't that great because it needs to go through all the points, but you get the idea. So that would be your graph. And then the table, I'm going to kind of squeeze it in right here. I'm going to do the following points just for sake of ease, I guess. So if we plugged in 0 for x, 2 times 0 is 0, -8 is -8 and -8. Plug in the 1 for x, 2 times 1 is 2, 2 minus 8 is -6. Plug in 2 for x, 2 times 2 is 4, 4 minus 8 is -4, and it looks like we've got a pattern going, which is good. So we can assume the next point is probably going to be -2, so 3 times 2 is 6, minus 8, -2. Customer C now has everything they need. They have a graph, they have a table, they have a rule, and they are set to go. Good job, Customer C. Let's see how Customer D did. Customer D, oh, we have all the way to Customer F. Sorry, there's a plane or helicopters. Okay, Customer D has a table that looks like this. So we have -3, -4, -2, -1, -1, 2, 0, 4, 1, 7, 2, 10, and 3, 13. So there's the table. And this, oh, it doesn't even give us a rule. It doesn't even give us a graph. So let's look and try and make a rule for it. So I see a good starting point for our rule, y equals something, because we don't know the pattern yet, but we do see our y-intercept is 0, 4. So I'm going to put +4. And then let's see if there's a pattern going from y to the right. So let's see, that looks like -4 + 3. That works. -1 + 3, that works. 2 + 3, uh-oh. 2 + 3 is 5, not 4. That works though, that works. So that one messes us up. We cannot order this line for him because it is not a consistent growth. So if he found points that had a consistent growth, because that's +2, that's not going to work because we need one consistent number here, and that is not correct. So Customer D will not be able to order the line. He does not have a consistent pattern. Sorry. All right, going to part E. Customer E ordered the line 2x minus y equals 4, and he wants the line to grow by 2 and pass through the point 5, 6. Let us see here. It's still recording. Yay, it's still recording. Okay. Here's what I did first. I wanted this equation to be in y equals mx plus b form, because right now it is not in y equals mx plus b form. I'm going to erase what I just put here so I can have room for that. Okay, so I want y all by itself on the left side. So I need to get this 2x to this side, and to get a positive 2x to be removed, I minus a 2x. And I'm left with negative y equals, and I'm gonna just switch this around to negative 2x plus 4, because that's in my y equals mx plus p form. Last thing I need to do, I want a positive y here. So I'm gonna divide everything by a negative 1. And I'm left with y equals 2x minus 4. So there's our final form. Y equals 2x minus 4. So it looks like his first requirement was that it grows by 2. Does this line grow by 2? It does, because there's our growth. It grows by 2. His last thing that he wanted was that it passed through the point 5, 6. If you want to figure out if a point is on a line, you plug in these values for the x and the y in the equation. So let's plug 5 in for x and 6 in for y. So 6 equals 2 times 5 minus 4. 6 equals 10 minus 4. 6 equals 6. So it looks like this customer is correct. So if he is correct, we need to provide him with a table, a graph, and a rule. And we already found out his rule is y equals 2x minus 4. Let's do his graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. And we're starting at 0, negative 4 as our first point. So 1, 2, 3, 4. And we are growing up 2 over 1. Up 2 over 1. Up 2 over 1. Sorry, this is a little skewed. 1, 2 over 1. Ooh, that does not look good. Let's make it there. Oh my goodness, yeah, that should have been a lot straighter, but obviously our graphs are not going to be precise if we're not using graph paper, but you get the idea. All right, let's make a table. I just did the same points as last time. I did 0, 1, 2, 3 for my x. So let's plug in 0 for x. 2 times 0 is 0, so that means y equals negative 4. 1 times 2 is 2, minus 4 is a negative 2. 2 times 2 is 4, 4 minus 4 is 0. 3 times 2 is 6, 6 minus 4 is 2. So it is going by 2's. That is customer E. And the last customer, customer F. Okay, customer F wants a line that starts at 0, 1, grows first by 3, and then by 5. So there's a red flag here, and the red flag is the pattern is not consistent, because this person wants it to grow by 3 first and then have a pattern of 5. So this is not a linear line, which means it's not a straight line, and we cannot fulfill his order. So let's see, we wouldn't know where it grows by 3 and by 5. We don't know which point it does that at. So unfortunately, incorrect, because the line is not linear, which just means straight. We don't know, we need more information about this one. It's not linear, we can't draw a straight line for it. So that would be customer F. All right, that's actually the rest, that's actually all of this lesson. And we are going to end there. And you can see my dog Bailey outside for a sec if we... There she is. Bailey. Oh, she's amused with other things. I'm not amusing to her. Bye, Bailey.